Now we will see why is hash and previous hash is important. Well, let's imagine that someone tries to change something inside any blockchain. So there is a hacker who says that this block number 2 contains a transaction. Let's say that he received 1 Bitcoin, wants to change it to 1000 Bitcoin. So he makes that change. And as soon as he does that, the fingerprint of that block, the hash of that block changes. And now block number 3 has a problem. When we validate the chain, block number 3 will say, the hash of block that went before me should be different. But now something has changed. What is going on here? So nothing prevents we from changing data inside the blockchain. But as soon as we do, we can see that someone has tampered with that data. Now we are thinking, if I am the attacker, I just move along to block number 3. Change that until the hashes match up. I just link up block number 3 with block number 2. What's preventing me from doing that? Well, there are two security mechanisms that make sure that that cannot happen. That is a consensus algorithm and a peer-to-peer network. We might have heard about proof of work and proof of stake. So let's look at that consensus algorithm. A consensus algorithm basically slows down the creation of blocks. In the case of Bitcoin, we can only create a block every 10 minutes. We cannot do it faster than those 10 minutes. How does it work? Well, it's basically a cryptographic puzzle. We need to do a lot of intensive calculations to be able to solve this puzzle, and those take on average around 10 minutes. We call this process mining in case of proof of work. So in this case here, I have a blockchain of 2 blocks. After block number 2 has been added, it will take 10 minutes for the third block to be added. 10 minutes after that, we will have a fourth block and so forth. Now this impacts an attacker as well. If an attacker changes something inside block number 2, he has to change that cryptographic proof. He has to change that puzzle, and that will take him at least 10 minutes. If he has really powerful computer hardware, it might take him a lot longer. And then he moves on to block number 3 to make the chain valid again. And that one will take him again 10 minutes. 10 minutes to completely rework that puzzle. But by that time, the network will have already added a fourth block to the chain. And so the idea is that an attacker can never catch up. He is always running at least one block behind. And the second thing that secures blockchains is that peer-to-peer network. Those people that are creating consensus amongst each other. Everyone is constantly validating the records that they have. And as soon as they see that someone comes around and tries to change what already happened, they will just ignore him and say, you are not part of our network because you are not playing by our rules. So to summarize what a blockchain is, it's completely distributed. There's no middleman. Everyone can transact from one person to other. It's open for everyone. If we have a computer and we have an internet connection, we can join this network and become a part of it. And blockchains are completely immutable, which again means we can only add new transactions to it or new data to it. We can never change something that was already created. How does this relate to cryptocurrencies? Well, cryptocurrencies are built on top of blockchains. In fact, we could say that they are an application or a use case of blockchain technology. And I mentioned before, we can use blockchains for other things. For example, as a notary to timestamp documents or to keep track of our will or contracts or patents. Cryptocurrencies are just like that. They are an application of blockchain. So that is how blockchains work in a nutshell. To summarize, cryptocurrencies are just a form of currency, just like euros and dollars, except in this case, they are completely digital. They work without any intermediaries. There's no banks, no central banks, no governments. It's just the people and it's peer-to-peer. Everyone is equal. Anyone can join this network. There are no requirements. There are no restrictions. Now at this point, we might have two questions. How do I get crypto? And if I get it, where is it stored? If it's not physical, where is it? We will see that in next video.